Let's talk about some algebra of functions. By algebra we mean adding function, dividing function, multiplying function, subtracting functions. Functions are similar to numbers in some sense. Two numbers can be added to get a new number. Two numbers can be subtracted to get a new number. Two numbers can be multiplied to get a new number. Two numbers can be divided to get another new number. 4 and 2 multiplied gives 16. 4 and 2 adding gives 6. 4 divided by 2 gives us 2, and so on. The same thing is true for two functions also. In fact, two or more than two functions. Two or more than two functions can be added to give us a new function. Two or more functions can be subtracted to give us a new function. Two or more functions can be multiplied to get a new function and divided to get a new function. The sum of two functions f and g. The sum of two functions f and g. Let's say one function is f of x, another function is g of x. The sum of the two is represented by f plus g. And if we want to find sum of the two functions f plus g of x, this is basically f of x plus g of x. So if f of x is x minus 6, this new function will be x minus 6 plus g of x is 5x squared. So if I rearrange it, it will be 5x squared plus x minus 6. So I added the two given function f of x and g of x to get a new function which is 5x squared plus x minus 6. Very simple. Adding two functions means basically add their formulas. The same thing holds true for the difference. If we want to find difference of two functions, basically subtract the formulas of the two functions. So in this case, x minus 6 is the f of x, g of x is minus 5x squared. So if I rearrange them, I'll get negative 5x squared plus x minus 6, a new function which came by subtracting the two given functions. Product f times g. This is the product of two functions. Product of two function is basically multiplying the formula of the two functions. So in this case, one function is x minus 6, another function is 5x squared. So if we multiply them down, 5x squared times x is 5x cubed, 5 times 6 is negative 30, negative 6 is negative 30x squared. So this is the new function coming by multiplying the two given functions. The next, quotient, dividing the function. This is also simple. This is equal to f of x over g of x. However, we have to make sure when we are dividing two quantities, we have to make sure denominator is non-zero. So this formula, the dividing two functions, works by dividing the formula for the two functions. However, we need to make sure the function in the denominator is not 0. So in this case, this is equal to f of x is x minus 6, g of x is 5x squared, and we should mention x not equal to 0 because for x equal to 0, the function in the denominator is 0. In order to make the function in the denominator non-zero, we need to mention that we can apply this formula whenever x is not equal to 0. Well, sometimes what happens is rather than just finding the formula of the sum of the two functions, we might have to answer question of this type. Let's say the question is find let's say the question is find f over g of 2. There are two different ways we can solve this question. We can find this. One, plug in x equal to 2 here in this formula. One way, find the formula like this and replace x by the given number, which is 2 here. One way. Another way is just find f of 2 and g of 2 individually and divide them. According to our formula, f of 2 is 2 minus 6, which is minus 4, and f of g of 2 is 5 times 2 square is 4, so this is 20. So f divided by g of 2 is equal to negative 4 by 20, 4 cancels out, negative 1 over 5. Okay. Now let's talk about one more way of combining two functions, and we write like f o g of x, and this is called composition of the two functions. So composition of the two function works this way. Take f, replace this o, the symbol for composition is little o. Replace the o, the symbol for the composition, by parenthesis, and put g of x inside. This is the formula we apply to calculate composition of two functions. Well, let's see how it works. F is f, g of x in our example is 5x squared. Note, in our example, f of x is x minus 6. So what this formula is telling is, well, in order to compute f of 5x squared, basically we need to replace x by 5x squared. So f of 5x squared will be, I am replacing in this formula, I am replacing x by 5x squared. So I will get 5x squared minus 6. This is how we can compute the composition of two functions. Notice this composition and the product f times g and f compose g are two different things. In case of product, when multiplying two functions, f times g, this will be the same as g times f, because in order to find g times f, we multiply g of x with f of x. Multiplying g of x with f of x is the same as multiplying f of x with g of x. Multiplying two numbers, as long as the two numbers are same, it does not matter which number we keep in the first place and which number we keep in the second place. 5 times 3 is 15, 3 times 5 is also 15. So, however, in case of composition, if I switch the order of the two functions, we will get a completely different function. Let's see in this example. Suppose I want to find GOF of x. So I am switching the order of g and f. If I want to compute GOF of x, g remains g. The composition sign will change into parenthesis f of x. Well, I know f of x is given to be equal to x minus 6. And we already know g of x is 5 times x squared. Now g of x minus 6 is nothing more than 5 times x is x minus 6 squared. See, 5x squared minus 6 and 5 times x minus 6 squared, these two things, they are not the same. They are not the same. So when finding composition, which function comes first, which function comes second matters. FOG and GOF are two different quantities.